Last episode, I built a roof rack and drove through the Alps. I didn't have a bed. That's been fixed. This is the most sophisticated campervan bed you'll ever see. I know that's a bold claim. By the end of this video, you can decide if I'm right. There's a reason why I spent considerable time and money on this part of the build. Sleep deprivation isn't just feeling tired. Studies consistently show that it impacts cognitive function, physical recovery, reaction times, mood, everything really. Most van conversions compromise on the bed, whether that's having to sleep diagonally, complicated bed setups, or tucking a body part or two into a cubby in order to fully stretch out your body. An obvious solution, and arguably one of the most popular in the van conversion world, is using a Scorva bracket, which is an IKEA product, and it enables you to span from one end of the van to the other to create a bed platform in order to build from. They're cheap, they're strong, and they're relatively lightweight. And I actually had 3 of these brackets ready to go, which I have now returned to IKEA. The reason I returned those and couldn't make them work in my van is that my van's a medium wheelbase, and I wanted fixed benches and a table big enough for 4 people, as well as a full-size double bed. That just isn't going to fit inside a medium wheelbase van if your bed is fixed. I chose a medium wheelbase because it's smaller and, in my opinion, fits my needs better. It can park almost anywhere and go to a lot more places that a long wheelbase van cannot go. And if my planning works out the way I hope, I'll be able to fit absolutely everything in this van, including a full-size double bed, which I'm in now, benches large enough for 4 people and a table, a shower, and a large kitchen. People often say that converting a van is all about compromise, and you have to sacrifice certain things in order to have others. Well, I didn't want to sacrifice anything on my list, so this is what I've done. A full-size double bed, which lifts up into the ceiling to reveal benches underneath and plenty of storage. So here's how I built it. Before a single piece of extrusion was cut, I modelled the entire setup in CAD, checking clearances, bed travel height, fold-out geometry, and how everything would sit relative to the bench frames either side. The solution is a motorised lift system using 4-column actuators. These aren't the cheap piston-type actuators you'll find in most DIY builds. They're self-contained column units that don't need rails or guides to run in. When the bed comes down, there's nothing on the walls. No rails, no hardware, just a clean van interior. Belted systems exist, motors and straps, but belts can wear and tangle over time. DIY rod actuator kits are out there too, but they need guide rails on the walls and can't handle lateral load. Cheap actuators off AliExpress, mixed reviews, no warranty. Either way, you're looking at £500 to £1,000 and still compromising on quality or aesthetics. There's nothing at this spec, so I built it. The frame is built with 40/40 aluminium extrusion, the same profile I used on the roof rack. The bed sits at just under 1.7 meters elevation at full stroke, with bench seating and a table underneath when it's raised. The whole space transforms depending on whether you're sleeping or living in it. The build starts with dry fitting everything, checking dimensions, clearances, and that the whole thing actually looks right before anything gets tightened permanently. That dry fit step matters more than you think, because this structure has around 400 T-nuts in it. Every single one needs blue Loctite before final assembly. Vans vibrate, and anything that can work loose eventually will. So the process was, build the whole thing, check it, take it completely apart, Loctite every bolt, rebuild it. So this should fit nicely, allowing a small gap for the inverter. I just need to work out how I'm going to attach these to the rest of the extrusions. So I do have some of these 90-degree plate connectors, which could just about fix into here, but that would only work for the ends, and I would need to grind off this section here. So I'm thinking of 3D printing some very sturdy brackets for the backs. So here is my solution. 3D printed brackets made from ABS plus filament, which end up being super strong. This one's got a bit more flex in it, as you could expect, but still decent for this application. So that's pretty good. There is still a little bit of play in it. It will obviously be attached at the back here as well. But I think what I'll do with these end ones, which won't have two of these corner brackets, like the central ones on each side, is I will also make some plates to go on the end as well. Absolutely solid. The bench framework uses 2020 aluminium extrusion with custom fabricated brackets cut from an aluminium diesel heater housing I had lying around that nobody wanted to buy. This would be a lot better, faster, more accurate with a plasma cutter or a CNC mill or something, but I don't have that luxury at the moment. Nicked myself with the grinder on the last connector. Sod's law. I also want these aluminium plates that the actuators are going to sit on to be fixed to the extrusions below. So I'm going to drill some M5 holes and then countersink some wider holes so that a bolt can sit flush with the panel, meaning the actuator can sit flat on here and can bolt nicely to the actuator. Looking a little rough, but these will get etch primed and painted before their final install. The bed base is 5.5mm exterior grade eucalyptus ply, one sheet, ventilation holes throughout to allow airflow under the mattress, painted both sides for moisture resistance. The speed controller housing is 3D printed in ASA, custom designed to mount on the electronics board alongside the rest of the van's electrical system. Same approach as always. If the right part doesn't exist, make it. The brain of the system is a Raspberry Pi connected to a 7-inch touchscreen and a 4-way speed controller via a Modbus RS485 connection. Up, down, stop, home, all controlled from the touchscreen. I'll be honest, the Modbus connection was the most frustrating part of this entire build. With no coding experience, I used Claude Code to write the software, and even with AI doing the heavy lifting, there was hours of back and forth getting it to communicate correctly with the controller. This is what the process looked like, not glamorous. After hours and hours of troubleshooting, this is one of the most satisfying sounds I can hear right now. Nice. The real question now is whether I change the voltage to 24 volts and then these would move at twice the speed. From my manual tests before these were hooked up to the tablet, it takes 60 seconds for the actuators to go to their full height. So I need to decide whether that is fast enough or whether it's worthwhile me switching to 24 volts, which would mean that they would move at twice the speed, so 60 seconds. Let me know in the comments what you'd do. Super happy with that. The actuators have configurable parameters, speed, acceleration, and stop limits for both the up and down positions. I assumed I could set the bottom limit above the physical lowest point of the actuator, so the homing cycle would stop there rather than driving all the way down to the mechanical bottom. That's not how it works. When you run a homing cycle, it has to go to the physical bottom of the actuator, regardless of what the parameter says. So my bottom position and my home position weren't matching. The fix was straightforward once I understood this. All I had to do was raise the actuators up by about 54mm, so the physical bottom matches exactly where I want the bed to sit. 2 2020 extrusion offcuts stacked on each side and a 3D printed PETG spacer to make up the difference.
Solid.
The touchscreen will be flush mounted on the kitchen side of the dividing wall. The touchscreen interface you're seeing right now is temporary. The Raspberry Pi will eventually run all the van's electrics from this single screen. The infrastructure is in place, the rest just needs to follow. A quick shout out to Gimson, Robotics and Electromen. Both companies provided meaningful support getting this working. Not sponsored, just worth acknowledging. And if you're in the market for something similar, I'd definitely recommend these two. The mattress is a custom 3-section piece, all stitched together as one, made by a UK company. When the bed is raised, the 2 end sections fold up onto the main bed base. When it comes down for sleeping, they fold out flat onto the plywood bench tops either side, creating a seamless full double surface. One corner has a 10 by 10 centimeter notch cut into it. One thing worth mentioning is obviously that this is not a finished article, and there's plenty of refinement that's going to be done as the van build continues on. Right now, it looks like a fairly well engineered project, and a lot of the refinement will come later. So try and use a little bit of imagination if you can. The total cost and weight is on screen now. Feel free to pause. Worth mentioning that this figure includes the entire bench framework and part of the framing for the rest of the van, not just the bed lift itself. So that's it. The bed situation is finally resolved, and I can move on to other exciting parts of the build. Next up, 100mm lift kit, full suspension upgrade, and all-terrain tyres. See you in the next one.